Hey, what's up guys? This video is for section 31, which is graphing linear equations. And this is one form that you guys need to learn that is called standard form. You guys are going to learn a couple more throughout the year, but today for this video, we are looking at standard form. Now, the first thing you have to learn is what is a linear parent function? What does it look like? Where does it come from? And then after that, you guys can have a better understanding of what is a linear function. Now, let me tell you guys that throughout your math education, your math career in high school, you are going to learn different functions. The names will change, the shapes will change for those functions, but every function that you guys graph actually comes from a parent function, the most basic function graph that you can think about that specific form or for the graph. So a linear parent function, first of all, the word linear, you guys will have a line. Some graphs, they have a curve, not a line. They might have a V shape, they might have an S shape, or something that looks like a roller coaster. So every function is different. Here we have a linear function. The linear parent function looks like this here in function notation. F of x equals x. Or you can change the f of x to a y equals x. Now that is the most simple, the most basic linear parent function. When you guys build different functions which are linear, you can start having different numbers next to the x, or fractions, or negatives and positives, and that's where the shape or the graph will change. Now for the linear parent function, the graph looks just like a straight line, just like this one here on the screen. Notice that that linear function crosses the origin right here, and it goes uphill. That is what is called the parent function. Now, when you guys have a graph, you can make one by using a table. You can actually graph a linear function using a table. That's why I have a table here. Now, this table represents the parent function for linear functions. If you notice, when you guys have x values here, we have -2, -1, 0, 1, and 2. You can find the y value by substituting that x value into the y. And this is going back to evaluating functions, or evaluating when you have f of x. So if you substitute -2 into the x here, so -2 goes here, that's going to be y equals -2. If you substitute the -1 here, y is going to equal -1. So notice that the x and the y's are the same for the parent linear function. Now, if you guys do not have the parent function, those numbers are going to be different. So from a graph, you guys can have a table, or using a table, you can actually make a graph. And that's the first step we're going to make today. We are going to graph linear functions using a table. Later on, I'm going to show you guys how to do quick graphs, not using a table, by using the standard form. That's going to be the second video. I'm going to have to do a part 2 for this section. But also, you have to understand, how do you know when you have a linear function? Not all the functions out there are linear. Like I said, like I mentioned before, you can have a U shape, like a curve. You can have an S shape. You can have like a roller coaster going up, down, up, down. So there's different functions in mathematics. But how do we know when we have a linear function? Well, first of all, x is not part of a denominator in a fraction. That's how we know a function is linear. Then x and y are not multiplying another variable. So x cannot be multiplying with the y, x, y. For example, you cannot have x, y plus 1 equals y. That cannot happen because the x and the y cannot be together. They cannot be multiplying a different variable like a z or a p. And x has an exponent of 1. That's the last one. Now, all of this here has to happen in order to say it's a linear function. It's not just one that can happen. It has to happen for all 3 bullets here. And if it does, then it is a linear function. Now, for the first one, if you guys cannot imagine x cannot be part of the denominator, this is what I'm talking about. you guys cannot have something like 1 over x plus y equals 7. Notice the x is on the bottom denominator of the fraction. That cannot happen if you want to say it's linear. If it is on the bottom, it's not linear. It's a different function. So you guys will learn that later on in your math classes. But here for this video, we're just focusing on linear. So once again, you guys need to have all these three things happening at the same time so we can say it's a linear function. So let's go ahead and graph using a table first, and then we are going to move away from the table, and I'm going to show you guys how to graph linear functions when you have the standard form. And I'll explain what that is as we move on. Now, for the table, notice that on the table here, I do have 1, 2, 3, 4, 5 different order pairs. A table can be as big as you want. You can have 5 order pairs. You can have 10 order pairs. You guys can have 3 order pairs. You guys can have as many as you want. But every time we want to graph, we want to know what happens when the x values are negatives, when the x values are positives, and what happens when x equals 0. So that's what we want to know. We want to see what's going to happen when those numbers are negative, positive. I'm not going to choose numbers when you make a table, when you construct one. You don't have to choose numbers that are really high. For example, negative 10 or positive 10 or negative 15, positive 15. You guys don't have to do those. The easiest numbers that you guys can use are the ones here, negative 2, negative 1, 0, 1, and 2. Some teachers, they actually just use the negative 1 for the x, the 0, and the positive 1. So it depends on the teacher that you guys have for mathematics. I like to use all these numbers here because it gives me a better idea of how the graph is going to look. So I'm going to use a table just like that, and our job when we construct a table, we are going to have those x values, okay? Well, if you guys don't have them, usually the teacher gives you guys a table with the x values. But if you don't have the x values, you're going to have to choose on your own. You're going to have to choose those x values. And like I said, these are pretty good numbers that you can choose for x's. Maybe your teacher will give you guys a table with x values that are not these numbers. The table might have a negative 6, it might have a negative 5, it might have a positive 3. But the concept, the idea is the same. You guys need x values to find the y values. So this is where we're going. We are going to have inputs and we are going to find the outputs. That's what we want. I need to find those points so we can graph the points and then you guys connect. And notice what happens when you guys actually have the points. If you graph the first one, the first point is negative 2, negative 2. I'm just going to write it as an order pair so you guys know that it's the same thing when you guys graph. Negative 2 is here. Negative 1 is here. The next one, 0, 0, 1, 1, and 2, 2 is the last point. 2 to the right and 2 up. Notice that when you connect those points, you are going to make a line. That's why it's called a linear function. So let's get to an example and let's graph by using a table. So before we actually graph with the table, I just want to go over when you guys compare linear functions, nonlinear functions, because it's very important that you guys know what type of function you guys will have. Like I said, later on you're going to learn about what are called quadratic functions. Those are not lines. They're going to be U-shapes. You guys have cubic functions. You guys have square root functions. So you really have to understand what type of function you guys have. Now, today, we just look at linear functions. So here I have some examples of linear functions and not linear functions. So the first one, notice, all of this side here are linear functions. Y equals negative 2x plus 3. Now, the three things that you guys need to remember. X cannot be on bottom of the fraction. It cannot be a denominator. X and y cannot be multiplying another variable or each other, and x has to have an exponent of 1. So this x has an exponent of 1, it's not on bottom of the fraction, and the x and the y are not multiplying each other. That's why this is a linear function. Over here, well, right away, I notice this x has a squared. It has a different exponent, not a 1. Now this one, it has an exponent of 1, but the problem is this x here. Since it has an exponent of 2, a square, not linear. Now this one here, it is linear. Notice you guys have the x with an exponent of 1, x, exponent of 1. X and y are not multiplying. We don't have x on the bottom of the fraction. It is linear. This one, not linear because right here, x and y are multiplying. There's nothing in between, so by default, those are multiplying each other, not linear. This is another example of linear functions. Notice we do have a fraction, but the x is not on the bottom. The 3 is on the bottom, it's a denominator. The x is on the side of the fraction. So you guys have a fraction 2 over 3 times x. So that's okay. And x has an exponent of 1. So this is a linear function. X and y are not multiplying each other. Notice this one over here. X is on the bottom of the fraction. It's the denominator, not linear. Now this one doesn't have an x, but it is a line, linear function. When you guys graph, it will make a line, and it is going to be a linear function. So I'll explain that in a few minutes. Now over here, you guys do not have a linear function because once again, there's the fraction, x is on the bottom of the fraction, and it has a square. So not linear. All right, guys? So make sure you understand if it's a linear function, not linear function. And from there, you guys can graph. So let's look at this example here. We want to graph the equation by making a table. Once again, we are going to construct or make a table with the x values, the inputs, the y values, the outputs. You guys are going to graph the points, and then you guys are going to connect to make your line, the linear function. Now here, we do have function notation. F of x equals 2x minus 1. Now that's one way you guys can see a linear function. And I know it's linear because x has an exponent of 1. If you guys want to change the f of x to a y, that's fine. Remember that you guys can interchange those. F of x is the same thing as the y. So you can put here or y equals 2x minus 1. So the x and the y are not multiplying each other, and x has an exponent of 1 and it's not a denominator. The x is not on the bottom of the fraction. So we need to have a line. When you construct the table, notice I don't have a table here. So if you don't have one, you can make your own table by using a t-table. And this is what I like to use. I make a t-table like this, and notice that this is kind of like a long t. That's what we call it, a t-table. Sometimes you guys have a table going sideways from left to right. That's an horizontal table. The direction of the table doesn't matter as long as you pay attention to the x values and the y values. So notice I have the t-table. Now I'm going to choose my x values, my inputs, and I'm going to look for my outputs, the y values, so I can graph the order pair. The numbers that I like to use are -2, -1, 0, 1, and +2. Now, like I said, your teacher might tell you guys something different, but you can use any numbers. If you guys have already a table on the paper with x values, you don't have to worry about choosing x values. You just use the ones they give you. But right now, we're going to use these numbers here. Now, the idea is to substitute this input into the function. Now, you guys can use the function notation, or you can go over here. And I like to use this format because I'm looking for the y value. So I'm going to substitute the -2 into the x, and I'm going to simplify. I'm going to evaluate for the y value. And I'm going to do the work on the side so you guys can see that I'm going to substitute. So there's the y equals, and I have the 2 times the -2 minus 1. You guys do the math. You guys can use the calculator, mental math. You multiply these two here. 2 times -2, that's -4, minus 1, that's -5. So that's your y value. This first y value is -5. So I'm going to put a -5 right here. So that's my first order pair. My first order pair is -2 and -5. And notice I put a line here so I don't get confused. I know this is a pair of numbers, x, y, input, output. Now you guys are going to do the same thing to the next x value. The next x value is -1. So you go way over here and you substitute the number into the x to find the y. So I'm going to do that right now. Y equals 2 times -1 minus 1. You guys do that mental math, and the answer is -3. So you guys will put a -3 for the y value. Now once again, you can use a calculator or use mental math. 2 times -1 is -2. -2 minus 1 is -3. Now you guys can pause and find the next numbers, and then we are going to graph those numbers. So there's the table. We finished constructing the table that we need, we can use to graph the points. So now you just graph those order pairs. So the first one is -2, -5. So you go -2, that's 2 to the left. And then you guys go down 5 and you make a point. So your point will be right here. Let me just show you from the origin. 1, 2 to the left. 1, 2, 3, 4, 5. And you make a point. So let's go ahead and do that right now and graph all the points. So after graphing all those points, I have 1 order pair, 2, 3, 4, 5 different order pairs. So I should have 5 points. 1, 2, 3, 4, 5 points. You guys are going to connect the points. You can use a ruler. You guys can use anything straight or try to connect the points just by making a straight line. And we have our linear function. There we go. So notice that I'm going to put arrowheads here. Notice that the line is connecting the points, and I am using arrowheads because this graph, the line goes to -infinity. Remember that the y values go to negative numbers down. So this one is going to -infinity, and up here is going to positive infinity. When it goes up, it goes to positive infinity. So it keeps going and going and going. So that's how you graph a linear function using a table. Now let's try this one here. Notice you guys want to graph by using a table. I don't have function notation because there is no f of x, but I do have the y equals -1/2 x plus 3. So now this one's a little bit tricky. You have to understand what's happening with the function. It is linear function because the x has an exponent of 1. X and y are not multiplying each other, and the x is not on the bottom of the denominator. You guys have a 2 on the bottom of the denominator. Now when you guys are making a table and you have a fraction, I'm going to give you guys a tip that you can use so you can make your life a lot easier, because I know students don't like fractions. Remember that you guys will make a table. So here's the x column, here's the y column right there. And you guys have a t table. The numbers that you can choose for x are the same numbers I gave you guys at the beginning of the video, the -2, -1, 0, and +1, +2. Now sometimes when you guys use those tables or those numbers and you substitute, you're going to get a fraction. So to avoid fractions, I want you guys to look at the denominator right here. And what you can do is choose multiples of that denominator. So here it's a 2. So multiples of 2's are 2, 4, 6, 8. I'm counting by 2's. So those are multiples of 2's. So you can choose those numbers. +2, -2, +4, -4. If you guys have a denominator, let's say of 3, you guys have 1/3. Well, multiples of 3's are 3, 6, 9, 12, 15. You count by 3, so those are your multiples. Do not choose 12, do not choose 15. Those are big numbers, but you guys can choose the 3, the 6, the 9, maybe 9. Sometimes I use 9, even though it's a little bit high for me. But you guys use multiples of the denominators, and that's going to make your life a lot easier. So I'm going to do that right now. Since I do have a denominator of 2, I am going to choose multiples of 2's. So I'm going to choose -4, -2. Now you guys can still use 0, because when you guys substitute 0, anything times 0 is going to be 0. So you're not going to get a fraction. And then I'm going to use the +2 and the +4. And that's because I want to know what happens to the graph when I have the negative numbers and the positive numbers, and including the 0. Now you're going to do the same thing here, but The steps are a little bit different than the previous example, so I'm just going to do the first two for you guys. I'm going to substitute this input, -4, into the x value. So we're going to substitute it here. So I'm going to have y equals -1/2 times -4, and then I'm going to have +3. So remember that when you guys multiply fractions with a whole number, you can cross simplify. So I'm going to do that. 2 goes into 4 2 times. So you have to be careful with the signs. Now the fractions is gone, or the fraction is gone. But we do have a -1 here times a -2. So -1 times -2, that's +2. +2 plus 3, that's going to be +5. So my first number for the y value is +5. So I'm going to put my line right there. So that's my first order pair, -4, +5. I'll do the second one to show you guys the process again. So I have the -1/2, that's the function, and I'm going to substitute the -2 into the x. So I'm going to multiply by -2 here and +3. You guys can cross simplify. 2 goes into 2 one time. Careful with the signs again. -1 times -1, that's +1, plus 3 will be 4. And notice that I'm not getting fractions. So that's what I want to avoid. That's why I use multiples of the denominator. So I can cross simplify and I don't have fractions anymore. So the next number for the y, the output is 4. So when the input is -2, the output is 4. So go ahead and pause the video. You guys can find the next 3 outputs. And I have my table already constructed. So notice I don't have fractions. I don't have to worry about those. I'm just going to graph the points. So we have 5 different points. -4, 5 is 1 point. -2, 4. And the next one, and the next one. So let's go ahead and graph those points. So I already graphed the points right here. Notice when you connect, there's a line. It is a linear function. It makes a line. Now something that I want you guys to also notice from the table, when you look at the y values, you guys can notice there's a pattern. So if we look at the y, the outputs, there's the 5, 4, 3, 2, 1. So when you guys make a table, you can find a pattern and you can follow the pattern to make the next point on the graph. But here's the catch though. The same pattern, or I don't want to say the same pattern, but the x values must have a pattern as well. It doesn't have to be the same pattern as the y values. So what I'm trying to say is here for the x's, notice that the numbers are increasing by 2's, -4, -2, 0, 2, 4. And over here is decreasing by 1. So in a linear function, you can find patterns. If you guys are missing one of those numbers here, you guys might not see the pattern. It can still be a linear function, but that's the problem when a t-table is skipping one of the numbers, is missing one of the numbers. A lot of students, they don't find the pattern. So what I suggest is for you guys just to construct the whole table, and once you guys have all the numbers for the table, you connect, you graph, you connect, and eventually it's going to be a linear function. All right, now the last thing I'm going to show you guys in this video is when you are missing one of the variables in the equation. So here I want to graph the equations, and notice I have 2 equations. One of them is y equals -2, and the second one is x equals 5. You can construct a table to graph these lines, but you don't really have to, because when you're missing one of the variables, you have 2 options. One is the line can be vertical, going up or down, and the second option is horizontal. The line can be going to the left and to the right. So here we have y equals -2. Notice that x is missing. You don't have an x. You have a y equals -2. When the x is missing, that's going to be horizontal line. So I'm going to put it here, horizontal. So the way you guys graph, you are going to go to the y-axis, just like the y equals on the y-axis, and you're going to go to that specific number, -2. If it's a +3, you guys go to the +3. But right now, we have a -2. So -2 is right here. And using that point on the y-axis, -2, you just make a horizontal line. So from left to right, notice I am going through the points, and that is my graph. Nothing else. I don't need to make a table. I don't need points. I know it's going to be a horizontal line crossing at -2 because the x is missing. So I'm just going to put the name of the line. Every graph, every function has a name. So this red line, the name is y equals -2. I'm doing that because I'm going to have a second line, which is x equals 5, on the same coordinate plane, and I don't want you guys to get confused. So when you guys do not have the y, just an x, y is missing, that means that your line is going to be vertical. So on the x-axis, x equals 5. On the x-axis, you go to the +5. 1, 2, 3, 4, 5. And you guys make a point. Let me do that again. 1, 2, 3, 4, 5. So I put a point right there. And I make a vertical line going up and down. Now I know this is not really straight. You guys can use a ruler again to make your straight line. And I'm going to write down the name of the function, or the linear function. X equals 5. So this vertical line is your x equals 5, and your horizontal line, that's when it is going to left and to the right, is your y equals -2. Notice the arrowheads, they're telling you that the line is going to +infinity, -infinity, so they keep going and going and going. And over here, you guys have the line going to -infinity and the +infinity. They keep going and going and going. All right, guys, so like I said at the beginning of the video, I'm going to have to make a second video. So make sure you guys check that out as well. We are going to graph in standard form for the second video. We're not going to use tables. And if you guys like my videos, you can hit that like button. You can also subscribe to my channel. Make sure you guys practice, and I'll see you guys later.